Okay, let's take a look at this question. First thing we want to do is draw this out. You always want to draw this. All right, so we've got our origin here. Here's 0. Q1 is located there, and he's positive, 6.6. Remember, nano means times 10 to the negative ninth coulombs. Micro with a mu would be -6. Nano is -9. Then we got Q2. Sure, I am. Yep. At 5 centimeters. Remember, we have to be in SI units. So this would be 0.05 meters. Here's Q2, and he's negative 2.7 times 10 to the negative ninth coulombs. We want to find the location, if there are any, where the electric fields will exactly cancel out. Okay, so let's think about what we got here. We got this positive charge. We'll draw him some blue lines. The electric field is going to go out away from him, and it's going to get smaller as we go further away. So close, we're going to get these big blue vectors, and smaller as we go away. And then we'll do this guy in red. He's a negative charge, so he's going to have vectors pointing in toward him that are big when we're close and smaller as we go away. And then here, still pointing toward, but smaller as we go away. Now, if we look in this region, those two different electric fields are going to add together, always pointing to the right. There's no way that the blue vector and the red vector will cancel out here in the middle. It's impossible. What about over here? Notice I got a really big blue because I'm close to this guy, but a really small red because I'm far away from him. He's bigger. So it's say that at this location right here, I'm closer to Q1, which wants to make his force bigger, and Q1 is also bigger, which wants to make Q1 blue vector bigger. There's no way this blue is going to cancel out this red. Any place over here, I'm always closer to the bigger one. The bigger one's going to win. So there's no way over here. But in this region, like say, maybe at this location, yeah, I'm closer to him, but he's bigger. He wants to win because he's closer. He wants to win because he's bigger. There might be some spot out here where those will exactly cancel out. So let's call that location right here. Let's assume it's someplace in this region, X. Okay, then we want to find, what we want is for those two forces to exactly cancel out. We already know they're going to have opposite signs. We need their magnitudes to cancel out. We need the electric field from charge 1 at X to equal the electric field from charge 2 at X. Now remember, electric field is K times the charge you're interested in absolute value divided by the distance squared. So at location X, in magnitude, the electric field from charge 1 will be K, 8.99 times 10 to the ninth, times the charge, 6.6 times 10 to the negative ninth, all over the distance. So I need this distance. I decided X is distance from the origin. So that's what X means. In this particular picture, this distance is X. Then E2, the electric field from charge 2 at that location, will be K, 8.99 times 10 to the ninth. The charge, remember in Coulomb's law, we always use positives. This is magnitude. So times 2.7 times 10 to the negative ninth divided by this distance squared. So here we're going to do a little thinking. If this whole thing is x and this was 5 centimeters, then this distance here will be x minus 0.05 meters. This was 0.05. This is x minus 0.05. The whole thing is x. Notice, by the way, that that is a positive number. Because of the way I set this up, x is bigger than 0.05. That's going to matter in a minute. So I want that squared. I want x minus 0.05 squared. I need these two to be equal and opposite. So in general, this was k q1 over his distance squared. This is k q2, again in absolute value, over his distance to the point squared, not distance from each other, distance to the point. The k's cancel. So when I set these equal, those k's are going to cancel. I'm going to get 6.6 times 10 to the negative ninth over x squared equals 2.7 times 10 to the negative ninth over x minus 0.05 squared. Now, okay, this is why I'm saying signs matter. Who's bigger here? If you were 100% sure that this quantity right here is a positive number, if you're sure x is bigger than 0.05, if you're sure you're in this region over here, we can use a trick. If you're not sure if x maybe could be a negative number, or if the location maybe is someplace in the middle here, so that this guy here is a negative, you can't use the following trick. The way to do this that will always work is cross multiply and use quadratic formula. So cross multiply, like I'll write that out. So you would have 6.6 times 10 to the negative ninth, x minus 0.05, quantity squared equals 2.7 times 10 to the negative ninth, x squared. So you would have to FOIL this out, write it down twice, FOIL it, distribute, get everything on one side and use quadratic formula. That will always work. However, if you're 100% sure that x and this guy here are positive numbers, we can take a shortcut. We can take the square root of both sides. So I'm going to copy this. This will not always work, but it does in this case. Here's a shortcut. Remember, if a shortcut always works, it's not a shortcut, it's just the way. Anytime somebody teaches you a shortcut, that means that thing doesn't always work. We're going to take the square root of both sides. Technically, when you take the square root of both sides, you're supposed to put a plus or minus. I don't have to because I've already figured out that x and x minus 0.05 are both positive numbers. So we end up with the square root of 6.6 times 10 to the negative ninth over x equals square root of 2.7 times 10 to the negative ninth over x minus 0.05. Square root of junk squared is just junk. Now I can cross multiply. Okay, I just went through the whole thing. Realized I made a mistake at this point and had to back up. So hopefully I recut this video so all of that is cut out. We're going to cross multiply. So this comes up here. So I'm going to have x minus 0.05 times root 6.6 times 10 to the negative ninth equals x times this guy, 2.7 under the radical to the negative 9. Now, I could just go ahead and type those in the calculator right now. I could go ahead and, this actually might make my life a little easier if I go ahead and divide this guy over. I could just distribute over here, collect all the x's to one side, but I think it's going to make my life easier if I go ahead and divide this over. Then I can put it under one radical. In fact, once I do that, these times 10 to the negative ninths cancel out. Or I could have just distributed and collected all the like terms and so forth. So what I have now is x minus 0.05 equals x times the square root of 6.6 divided by 2.7. Move all my x's to one side, get this constant to the other side. I wrote that upside down. I apologize. I'm not re-recording this again. At this step right here, we're going to get something very similar to what I had. This is on top, that's on the bottom. 2.7 times 10 to the negative ninth, 6.6 times 10 to the negative ninth. Because everybody's under the radical. First off, square root of a over b is the same thing as square root of a over square root of b. So I brought this guy under, and then I combined it into one radical. So I kind of work this backwards. I can cancel out these 10 to the negative ninths, and we get this. Now get all the x's to one side. Move. That is not an x. There's no x there. Move this guy to the other side. Now to combine these like terms, I just factor an x out. I get 1 minus this nasty looking guy here. And then because that's multiplying x, I divide, and here will be my final answer. And I can just type that in my calculator. And then I will, for completeness, do this without all that stuff I was doing with combining the radicals together. I'll show you if I had everything left inside there, how I would type this into the calculator, because a lot of times students have trouble typing scientific notation into the calculators. Make sure I'm out of the radical. I get 0.313, let's call it 0.139 meters, or about 14 centimeters. So remember, we were trying to find the spot over here somewhere. This was 5 centimeters. It's way down there. So it's like 9 more centimeters past. Okay, I want to go back to this step right here and do it the way most students probably would have done it. You wouldn't have thought, oh, let me just divide. And you'll see we end up getting the same answer, I hope. So let's distribute here. We'll get x times this radical, 6.6 times 10 to the negative ninth, minus 0.05 root 6.6 times 10 to the negative ninth equals this stuff here. I'm going to upload this document and attach it to the homework question. So I want to make sure all the details are correct here. Now we want to get all the x's on one side, all the constants on the other. When this moves to the other side, it becomes positive. And then same game here. I'm going to factor out this common factor of x. That equals all this stuff. And again, I'm writing this out in all its gory detail. And then finally divide. And again, the reason I'm going through all this is I know some of you will have your answer that looks like this, and I want to make sure you know how to type it into your calculator efficiently. Now, I'm not going to be able to play any fancy tricks combining square roots together, at least not easily. So let me show you how it would type this in the calculator. So 0.05 times square root of 6.6. Now, when you're doing scientific notation, you have a button that already does that right there, EE. So I hit second, that comma, EE. And that means times 10 raised to the, and now we got to type in the power. I want -9. That's your minus button. This is your negative button, -9. Divided by, I need parentheses here, square root 6.6 EE -9. Make sure I'm out of the radical, minus square root 2.7 EE -9. Make sure I'm out of the radical and close that parenthesis. And I get exactly the same answer. Equals 0.139 meters. Don't forget units. Okay, and then remember that was the shortcut. The right way, the way that will always work, is clean this up, meaning you got to FOIL that out. You got to write that down twice in FOIL. Distribute, get all your x's, everything on one side, and use quadratic formula. And that will always work. Okay, that's a good place to stop.